This is standard 1.2, find the height of various points on a wheel in relation to the ground, part 2. So in part 1, we talked about how to do this when the triangles are 45, 45, 90s. In this particular video, we'll look at what happens if we have 30, 60, 90 triangles. How do we determine, first of all, that we really do have 30, 60, 90 triangles, and then what do we do because we have these kinds of triangles. We'll stick to the same wheel as the part 1 video. So this particular wheel had a diameter of 50 inches, and the time for one rotation was 30 seconds. And in this problem, let's find the height of the gum at 12.5 seconds. So we're going to find the height at 12.5 seconds. So the first thing we have to do is figure out where 12.5 seconds is on our wheel. Then we have to figure out what kind of triangle we're using because of that, and then we're going to figure out the actual height. So step 1 here is find the gum, or locate the gum. Step 1. Okay. So what I like to do is take our total time for one rotation and divide it by 4. So every fourth of a rotation is 7.5 seconds. And that gives me some key values to place around our circle. And then from those key values, we can figure out where 12.5 is. So since 7.5 seconds is 1/4 of a rotation, let's start here at 0 seconds. And every fourth of a rotation counts 7.5 seconds. So from 0 seconds, we're now at 7.5 seconds. When we add another 7.5, we're now at 15 seconds. When we add another 7.5, we're now at 22.5 seconds. When we add another 7.5 seconds, we're now at 30 seconds. Now we have to find where 12.5 seconds is. So we know it's somewhere between 7.5 and 15 seconds. We have to figure out exactly where so that we can figure out whether we have 30, 60, 90 triangles or 45, 45, 90 triangles. So here's the center of our circle. Let's imagine these radii drawn here. And since a full circle is 360 degrees and we divided that wheel into 4, between each time that's indicated on the wheel here, it's 90 degrees, right? So that's a 90-degree angle. Now if we were to divide that 90-degree angle exactly in half, each of those would be 45 degrees. So the question is the time here exactly between 7.5 seconds and 15 seconds the time that we want, 12.5? Well, how do we find the exact middle here? There's a couple of ways. You can find the average of 7.5, and the average of 15 and 7.5 is 11.25. So exactly halfway would be 11.25, and that's not the time we're looking for. That's 12.5 seconds that we're looking for. So because it's not exactly halfway, we're not going to be using our 45, 45, 90s. Okay? So I'm going to erase this and see, well, if it's not halfway, let's try thirds. So if we divided this time into thirds, and we can do that. Here's 1/3. Here's another third. Let's see if I can erase this little tick mark here without erasing the whole wheel. Let's take this time from 7.5 seconds to 15 seconds. It's 7.5 seconds. And let's divide it by 3. And so that's equal to 2.5 seconds. And since we took this region here and divided it by 3, it's like we took the 90 degrees and divided it by 3 as well. And so between each tick mark, if we take 90 divided by 3, it's 30 degrees. Now let's count by 2.5 seconds. So from 7.5 seconds, if we add 2.5, we're now at 10 seconds. If we add 2.5 again, we're now at 12.5 seconds. And if we add 2.5 again, now we're at 15 seconds. So it seems like here is our gum. Now we're going to put our triangle into our picture. So to introduce our triangle, the hypotenuse of the triangle is the radius of the circle. And then from there, we're going to draw in our two legs. And notice that from one leg to the other, we've traveled two of these 30 degrees. So this is really 60 degrees in here. And so we have a 30, 60, 90 triangle. Furthermore, since the diameter of the wheel is 50 inches, the radius is 25. Now going back to standard 1.1, we can find the other two legs of our triangle because we know one side is 25. 25 is the hypotenuse of our triangle, so 25 is equal to the 2x side of our triangle. So now step 2 here in our process, after we've located the gum, is to sketch in the triangle with its measurements. All right, so we know 25 is the 2x side. Here's our equation, 25 equals 2x. And if we solve for x, we divide both sides by 2, we get x equals 12.5. Where does the x go? Well, the x side in our triangle is across from the 30 degrees. So across from the 30, we're going to put an x, which is 12.5. And the side across from the 60 degrees is 12.5 times root 3, x root 3. So now we have the triangle with our measurements. And the final step in our process here is find the height of the gum. So we have to figure out how far that gum is from the ground. Well, if we look at it in two pieces, this yellow piece right here and this green piece, if we add the yellow and the green together, we really have the total height of the gum. We know the length of the yellow segment is 12.5 root 3, and the length of the green segment is going to be the same as the radius because we really have rectangles down here. And so the radius of our circle is 25 inches, and the opposite side of a rectangle is also 25 inches. And so the total height from the gum to the ground here is going to be the yellow piece plus the green piece. And so that's 12.5 root 3 plus 25 inches. If we wanted to do the height at 10 seconds, we'd still have a 30, 60, 90. But now between the hypotenuse and the leg of our triangle, we have a 30-degree angle. So this would be 60, this angle would be 30, and it changes how things are oriented around our triangle. Same 30, 60, 90 because hypotenuse is still the radius, which is 25, but now this is our x side because it's across from the 30 degrees, and so that's 12.5. And so to find the height of the gum, we can add this blue piece plus this purple piece. And the blue piece we said is 12.5, which is the x side of our triangle. The purple is the radius, and we determined that earlier to be 25 inches. And so the height at 10 seconds is going to be 7.5 plus 25. Now because neither of these have a root 3 attached, then we can actually add these numbers, and I believe we get 32.5 inches as the total height of the gum. And so again, you have to think about when you draw your 30, 60, 90 triangle in here, where each piece of that triangle actually is. And are we using the 30 side, as we did in the second triangle, to figure out the height of the gum, or are we using the 60-degree side, as we did in the first triangle, to find the height of the gum? And that depends on where your angles lie. Let's do one more gum height. Let's find the height of the gum at 27.5 seconds. So we have to figure out where 27.5 seconds is on our circle. We know it's between 22.5 and 30. It's not exactly halfway in between. We could find the average of the two numbers like we did previously to confirm that. So let's figure out what happens if we divide this 90 degree into thirds. Again, each third is 2.5 seconds. So if we count by 2.5 seconds here from 22.5, this is 25 seconds, this is 27.5 seconds, and then we get all the way around to 30 seconds. So at 27.5 seconds, here's our goal. We want to find that green height. And in order to do that, we need to introduce our triangle. We did step 1, we located the gum. Step 2, let's sketch the triangle with our measurements. The radius of the triangle, the radius of the circle rather, is the hypotenuse of the triangle. And the question is, where does our 30 go and where does our 60 go? But between the hypotenuse and the leg of our triangle, we've only traveled 1/3 of this 90. So here's our 30 and here's our 60, right? Here's another 30, here's another 30 for a total of 90. Same triangle. So across from the 30 degree side is our x, which is 12.5. And across from the 60 degree side is our x root 3, so 12.5 root 3. Now we're trying to find the height of the gum, which if we look at our rectangle down here, really is the length of this green segment. So how long is that green segment? Well, the entire radius, now this picture is getting a little crowded, but this entire radius is 25. And part of it is 12.5 root 3. So if we have the whole radius and we have part of it, we want to subtract to find the other part. So we can take the whole radius, 25, and now subtract 12.5 root 3. And that's going to be the height of the gum at 27.5 seconds. Basically, if you're above this halfway point, you're going to be adding your triangle leg to the radius, 25 inches, which is what we did in the first and second situation here. And if you're below that halfway mark, you're going to be subtracting the side of your triangle from the radius, which is what we did down here.